these for the sake of our friends who are not here. Okay, and then there are, we're given this. What is this? The domain. Very good, very good. Okay, and now to ask the first question. How many cubic feet of rainwater flow in between t equals 0 and t equals 8? How do we do it? Integration? Okay, fair enough.
Integration
I want a sentence.
from 0 to 8.
Uh-huh.
RT
Mhm.
minus DT. And
Wait. It's only says something like that.
Interesting. Okay, so let's check this. We've got some controversy. Do we subtract the d of t or don't we? So, go ahead.
Well, first of all, even if you did need to include d of t in the equation, you'd be adding, because the equation already expressed the
Interesting.
Right. But the second of all, because it's flowing in, you only need r of t, which is how much better is
but
that?
DT is like right itself, so I'm so sorry.
Okay. How are we going to resolve this controversy? What do you think is going to help us? What am I probably going to tell you? But wait and see which one we like better. What stage advice do I give? Keeping your head straight. How about pay attention to the words? Pay attention to the words. There's words that close in.
Right now.
That's right. It asks how much is flowing in, and R of t is the rate at which water flows in. Therefore, finding how much flows in means integrating the rate of that, which is just R. Don't worry, we'll have R minus D later on. So we're going to have flows in. Here we go. And so now it's a matter of entering this into our calculator. We let y1 equal 20 sine of x squared over 35, like so. Second, out and integrate.
I have a quick question.
Sure.
The one thing that I realized when I was doing the Fourier response is that a lot of the equations that you use to calculate out take like a lot of time to constantly type it into your calculator over and over again if you're switching between graph and doing like integrating and combination. Is there a way to set like a variable equal to an equation so you can
You can. What I do is I just enter it once, and I don't go back and retype it. I let y1 equal that thing. And I'm going to be integrating from 0 to 8. There we go. This red line here was left over from a previous problem. I should have taken it out. Sorry about that. And we integrate to get 76.5704.
Oh, cubic feet.
Cubic feet. Good.
Big points here.
Is the amount of water in the pipe increasing or decreasing at time t equals 3 hours? Give a reason for your answer. What do we say? The sign of what? D of t. So I take a look at d of 3. And when I look at d of 3, oh wait, I don't have d in here yet, do I?
No.
Let's enter d. Minus 0.04 x cubed plus 0.4 x squared plus 0.96.
Wait,
Yeah. Me too. Make sure I've entered this correctly.
I just don't know why my calculator just keeps.
Well, I'm not liking it because the graph is giving me some negative values here. But that may be the way the cookie crumbles. 0 to 8. What does that even mean to have a negative amount of water draining out? Oh, this graph has no bearing to reality. Oh, yeah, it was confused. Okay, we're all better. Okay, so we get d of 3, and when we get d of 3, tracing along, that gives us 0.5.
Wait, this is
We get 5.4. Okay. What does that tell me? What does that even mean?
water drains out.
Water drains out at that rate. Okay, fair enough. Now we come back to the question: Is the amount of the water in the pipe increasing or decreasing? I need R.
Yeah.
I won't know unless I have R. So let me find R. So I go back to my other curve, and R of 3 is equal to 5.0864. Does this clarify my situation at all?
Yeah, that's up there.
Yeah, subtracting, if I subtract and I don't need this number, but Tommy had the right idea here. I looked at the sign, and the sign is less than 0. The sign is negative. So that's going to tell me that water, the amount of water is doing what? Is decreasing. The amount is decreasing. You did something totally different.
Yeah, I don't know why I did that, but like I do D prime D double prime. I do see the sign and I say
Oh, yeah.
yeah.
See, R and D were already rates, and so we
Right.
needed to take them as rates.
I know.
I had a lot more information than that, but I ended up with
Decreasing.
Decreasing.
Oh,
Cool. At what time t is the amount of water in the pipe at a minimum justify your answer? What are we going to do with this question? Well, eventually we are, but first what are we going to do with it?
Endpoint.
No. We're going to skip it, and we're going to come back to it, because it is an absolute extreme of question. Right? We're going to skip it and come back to it. The pipe can hold 50 cubic feet of water before overflowing. For t greater than 8, water continues to flow into and out of the pipe at the given rates until the pipe begins to overflow. Write but do not solve an equation involving one or more integrals that gives the time w when the pipe will begin to overflow. This was one of the more sophisticated questions on the exam. And it's going to require us to write some kind of an equation. How should I start that equation off? In a very simple manner. What's that?
30.
30. That's the amount of water in the pipe at time t equals 0. Good. Keep going.
Plus the integral from 0 to w of RT minus the integral from 0, from 0 to w of d of t
Okay.
equals 50.
Cool. Let's take a look at this equation and check it and see what it means. 50 is, of course, our overflow point. 30 is the amount that we start with. The integral of r from 0 to w is going to give me what? It's going to give me volume of what? If I integrate from 0 to w of r, what quantity do I get?
Total
That does what? That flows in, okay? So this is the total that flows in. If I subtract now d of t, I get the total that drains out. Let's take a minute to discuss the minus sign because you brought up that issue. Why minus? Well, because d of t is the rate at which water is leaving. And so we have to treat that as going out. The negative coefficient here in d of t, the equation for d of t, was not any sort of guarantee that we actually got negative values for d of t. Does that make sense? So what I've done here is the initial amount plus the total in minus the total out, and that total will be a total at W. And when that total is exactly equal to 50, then I have the W that I'm looking for. And that's exactly it. Nice job. Hold on. This was the most sophisticated question. Now coming back. At what time is the amount of water at a minimum justify your answer? You said critical points. How am I going to find them?
Find the values that relatively times the
Okay. Give me an equation.
Is R
Equal 0, right. It's not an equation until there's an equal sign. Right. Yeah. We want R minus D to be equal to 0 because that is the rate at which the water in the pipe is changing. Now, what I have in my calculator, this goes back to your question. I want to be clever here. What I have in my calculator is not R minus D. I have R and D separately. Can you think of a way to solve that equation, R minus D equals 0, without rewriting what I have in my calculator? Intersect. That's right. Second, calc, intersect. Hello. There. First curve, second curve, guess. That looks like a pretty good guess. And we get 3.2717 as our intersection point rate. Now, what do we do with that intersection?
So, put it in there. So find the value of
Okay.
0
We got a little lost. We're a little lost here because they're not asking us what the minimum value is. They're simply asking at what time is there a minimum value. So what do I need to do from here? What do you say, James?
If you plug in 3.26, I mean, plug in 3.67.
Well, I've got a time right here. Yes. I've got candidates. Right, what are my candidates?
Endpoints and
Endpoints and this point right here. Do I want to make an argument from critical points and endpoints? Or do I want to make an argument from the sign of electrons? Because I have how many critical points? One, it makes a lot of sense for me to look at the sign of r minus d. Let me call that T1 right here. And just looking at the graphs, I don't even need to evaluate. Is r minus d going to be positive or negative on this side? The r is the blue, the d is the red. Is r minus d going to be positive or negative? It's going to be negative there, and it's going to be positive here. That's right. So that we have r minus d is less than 0, or t is less than, not equal to, T1, and r minus d is greater than 0, t is greater than T1. So what can I conclude from that? Not just any old minimum, but an absolute min at t equals T1. And I don't actually have to compute any values whatsoever of my water in the pipe. I can, and if you did, then, and you computed them correctly, then you get the answer, but you took a lot more time to do it. So this was the lead-off question, and as you can see, it had a couple of tricks and traps in it. And my guess is that you guys picked up some points here and there, and a few of you may have gotten more than right. Questions? Let's take a look at number 2. We have, just curious, how many of you took a look at number 1 and said, let me go do number 2 and then come back to number 1? Couple. Okay, good. So that was an appropriate strategy, right? To go and do the ones that you can do quickly first. And I think number 2 was probably a quicker approach. We have F and G. They don't tell us which one is which, but I'm pretty sure that F is this guy right here. And G, pretty sure that G is this guy right here. And of course, the first thing I'm going to do is to enter F and G into my calculator. E to the and I should have cleared all this garbage out before I get started. Fine. Okay. And then here's G. Here. And I've got a little extra X there, which I do not want. Just check that. Did anybody find yourselves making typos when you punched it in the calculator? Yeah. So there was some of that. And I'm also going to reset my window size to match what is there. So I'm going to set my window size 0 to 4 here. And on the Y's, I'm going to go 0 to 3. Oh, excuse me, 0 to 2 here, and 0 to 5 here. And that graph now should look like their graph. Here comes F. Here comes G. And we're happy. And this graph, for some reason, doesn't match that one. Not sure why. Okay. And now they want us to find the sum of the areas of the regions of R and S. Who's got this? Kevin.
Integral 0 to 0 to 1, from 0 to 1, and then g of x minus f of x
Yes.
plus integral from 1 to 2 f of x minus 2.
Okay. Question, where'd the 1 come from?
Intersection point.
Is that the intersection point?
I don't think so. I'm not sure, I don't really remember.
Second, calc, intersect. First curve, second curve, and the guess is right there. Bam. 1.0328. Yep. What happened? You got mugged by doing trace instead of intersect, didn't you? You traced along and said, oh, that looks about right. But unless it says intersection, it's not actually an intersection.
But when I was doing previous, like when we practice test and practice response, the answer just said it's wrong. Even though I got intersect like 1 point something, the answer just said it's wrong.
Well, you should have asked about that because it's always the intersection. Always. It has to be, right? It has to be where those curves actually intersect. Yeah, you definitely should, when you, inconsistencies, things that you think should be one way but actually are the other, are the occasion for stopping, thinking, doesn't make sense, get some wisdom from somebody else on that. Yeah. Okay, now we're ready to do a little bit of calculus here. We're going to have to integrate y1 minus y2. So, what do I want to do? I can type all this again. This may be what you were talking about. I can do variables. Where's my variables? Here it is. There's y varies. y1 minus.
Oh my gosh, I wish I knew where you could hear this.
I did show you at one point.
No, I don't think it's that.
But yes, you can do that. Y1 minus Y2. Now, Y1 minus Y2 is going to give me, let's see here, negative for that part and positive for this part. So I can do second calc integrate. Second calc integrate from, and I'm going to integrate the third curve here, from 1.0, what did we say it was?
328.
328 to 2. And that gives me 1.0069. Now, rather than re-entering this, what can I do with what I've got to find the other one?
It's a negative integral from 0 to 1.2.
Yeah, I can integrate and take the opposite. So if I integrate my third curve here from 0 to 1.0238, 328, 328. Then I get negative 0.9974, take the opposite, I get that right there. My guess is they'll award the points like this. They're probably gonna give you 1 point for having the right G minus F, F minus G thing here. Probably 1 point for having the right limits of integration, and 1 point for this answer.
So they don't have to score a God one.
Oh my gosh, I got 1 point something. I got 27.
What's that?
For the answer, I got 27 something. I don't know how I got that.
Well, you can see that that would not be reasonable because the whole thing fits into
Two for the right.
the box here,
And like
which is
for
gonna
the
be
first
like a
interval,
variable.
for first interval, I got 0 for some reason. I don't know what.
I don't know.
Yeah, I just sweet.
So you had all of this in
Right.
that. Yeah,
Yeah.
so you get 2 out of 3, and that's not bad. Region S is the base of a solid whose cross sections perpendicular to the x-axis are squares. Find the volume of the solid. Okay, this is familiar territory. Tell me how it goes. Philip. Hi. I see that Don is distracting you a little bit. Why don't you bring your papers, come on up here where you can concentrate. We're on question 2, part B. Be careful.
Five. Wait, no. Integral. No, that's decent square. And the axis is from 2. No, like opposite. 2, 1, point. Excellent.
What do you use for S?
Well, we find the S value here.
Oh, you mean we're going to use the area here?
Yes.
No. Definitely no. What's that?
So B is equals to interval of 1 from 1.0 due to A to 2 and then AX dx.
Yeah. So our cross section dx. So did you draw a cross section on this?
Yeah, okay.
Okay. All right. And what's the side of my cross section here?
And then that'll be
Which one? It's got to be one of those. I think it's F minus G actually, because isn't F on top at this point? F minus G?
Yes, sorry.
Yeah.
Sorry.
Fortunately, it doesn't matter because when I square,
You got a positive.
yeah, like so. So now I have to come back. Are they really going to make me enter yet another thing into here? I'm afraid they are. I found that this question required a whole lot of calculator workout.
Mr. King,
Uh-huh.
can I ask you a question?
Yes, please do.
So how long have you been working on the problem?
How long have we been working on this?
I don't know.
We actually, less than you think. So, let's see here. We started class at 10:15.
Well, you can look at the time it started recording.
I am, that's true. So 30 minutes.
So,
So we're doing okay. Squared. And so now we're going to integrate that.
This question, like, I use a lot of time doing this question.
Yeah.
Yeah, the calculator is hard and just.
I agree. The calculator section took more than time that I think is really
Not just the one
appropriate.
in place.
Yeah, and then they give like less time instead of like giving a lot of time. And how like you cannot use calculator for 6 seconds. And you got like a couple of
So we're going to do our fourth, there. And that gives me 1.232832. Just like so. Okay, C, last but not least. Let H be the vertical distance between the graphs of F and G in region S. Find the region at rate at which H changes with respect to X when X is 1.8. Very interesting. This is a question that I haven't really seen before, so I come back and I ask myself, so what is the vertical distance between the graphs of F and G? Yeah. Oh yeah, that's true. It's just going to be the distance between the two is given by subtraction. So we have F minus G. Let's make sure it's F minus G and not G minus F. 1.8. So it's actually over here, right? So it is the black curve, which is F, minus red curve, which is G. And so now I'm looking at the rate at which H changes with respect to X. Spell that for me. H prime, yep. And given what I have here, I definitely want to find the derivative via calculator. So we do a little bit of second calc dy dx. My first curve is F. So I'm going to find its derivative at 1.8. And that's 2.1163. And I am going to find the derivative of G here. At 1.8, and that is 5.9280. And that's all I feel like really doing, because that's a good number right there. In passing, I notice that this is a negative value. Does it make sense that that's a negative value? Yes, the two curves are coming together, so their distance should be equal.
Why secrecy when the first?
Well, it depends on where you're looking, but we're looking at 1.8, and you can see that 1.8 is right about here. And you can see that at this point, these two curves are coming together. The distance is increasing.
All between these.
Yeah. So we finished these two questions. What I observed about these questions is that they are more calculator intensive than previous questions have been. Did you feel that? A lot more typing? Yeah. Did anybody run out of time on this?
Yeah.
Yeah, I think that's an experiment that AP is trying, because BC Calculus experienced the same thing on a different question, that there was a lot of calculator back and forth. So I think the message to teachers is we want students to be fluent with their calculators so that they can do stuff quickly and accurately. My guess is they're gonna have really low scores in this question. Okay, let's look at number 3, which is a much easier problem. Number 3, we have Johanna, who is jogging along. And her velocity is given various values. And now they ask us to use the data in the table to estimate v prime of 16. And we're back on familiar territory here. Tell me how it goes, Abby.
I did.
Hopefully you started with v prime of 16 equals.
Yeah.
Okay, good.
What did you do?
Or maybe even approximately equals. That's fine. They'll take either one.
What did you do?
Guys, I'm not sure what to do now.
Got it?
I did 20 minus 12.
Hopefully over 20 minus 12? Yep, that's it. And now it's just a matter of plugging in here. And we're missing only one thing, which is units. That's right. We copy those over. Meters per minute over minutes. And we are done.
Did you say meters per minute?
You can. You can do anything equivalent to this.
I think I need to take over unit.
Sorry.
Yeah.
Now, they didn't ask you for units, so they might not count off.
Oh, yeah. Oh.
But we have pride of professionalism. We're going to put our units.
I mean, I put minutes per minute.
Using correct units. Explain the meaning of the definite integral, blah, 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 0 to 40, absolute value of v of t dt in the context of the problem. What does this
Total
mean?
distance that she jogs along the street over 40 minutes.
Over 40 minutes,
No.
to be specific, on 0 to 40. Yeah. Good. Now we have to estimate that value with the right Riemann sum of blah, blah, blah. Casey, give us that estimate. Good.
No, I did the first part. And then
I have 12, 8, 4, and 16 as my intervals.
So, 12
Mhm. Yeah, go ahead. Keep going. Give me numbers.
12 times 240.
Now come back and just do a quick check to make sure this is exactly what you want. Tommy's noticing something. What you got?
I noticed that she wrote it backwards. T equals 1 0.
She did. Yeah. 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 We are integrating the absolute value of v. So we need to be adding up absolute values of v. So this needs to be positive. Yeah. And one more thing that we need. Units. What units will these be?
Meter.
Meters. That's right. And this is a perfectly good number, so we'll leave it just like that. C. Bob is riding his bicycle along the same path. For t between 0 and 10, Bob's velocity is modeled by b of t equals blah, 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 where t is measured in minutes and b of t is measured in meters per minute. Find Bob's acceleration, Matthew, at time t equals 5.
You take the integral, or not the integral, you take the derivative of b of t.
Okay, so I'm going to begin by spelling that as b prime of t.
And it's 2t, or 3t squared minus 6t,
No.
or minus 12t.
Yeah.
Sorry. And then you plug in 5.
So b prime of 5 is 3 times 5 squared minus 12 times 5, and except for units, what units would we have? Yeah. They didn't ask for units here either, so,
And ask me
in B.
yeah.
Based on the model B from part C, find Bob's average velocity. How is this going to go, Andrew?
So you're gonna use, what's it, the 1/b minus a integral of,
Go ahead.
so 1 over what's this? 1 over 10 integral from 0 to 10 of b of t.
How do I label this?
I wrote the add.
The average. That's a great way to do it. All right, keep going.
Well, b of t is t cubed minus 6t squared plus 300, so if you integrate that,
Yep.
yeah, you integrate that, then you get t to the 4th over 4,
Uh-huh.
and it's 6 times t equals 3 over 3.
Yeah.
Yeah, plus 3 over t, evaluated from 0 to 10.
Yep. And now it's just a matter of plugging in.
Yeah, and then just leave it.
Yep. And you just leave it. And that got us through the first 3 problems. That's a good job, guys. I'll see you on Monday. We'll do the other